Right, we're going to look at how to do binomial expansion with negative and fractional indices. Now the first thing we need to do is to adapt our formula, because our formula here is only going to work when n here, alright, when n here is a positive integer. Okay, and what we're going to do is we're going to adapt it to this formula here. Okay, this formula here, where n can be negative or it can be a fractional. Okay, and this formula at the top will work, whereas the bottom won't, because we can't do factorials with negative numbers or fractional numbers. I'm going to show how we can turn this bottom one, our familiar formula for binomial expansion, into one where we can deal with negative and fractional indices. So the first thing I'm going to do is I'm going to replace this a and this b with 1 and x in our normal expansion. So I'm now going to make a equal to 1, so replace the a with 1, replace the b with an x to the m. And we know that the formula for nc0 is n factorial over n minus r factorial r factorial. And we're going to replace that, so nc0 will equal n factorial over n minus 0 factorial, which is n factorial. That will give us n factorial over n factorial, which is just 1. 0 factorial is defined as being 1. So nc0 will just come out as 1. And we've got a is equal to 1, so we've got times 1 to the n times by x to the 0 plus, now here we've got n factorial over n minus 1 factorial, 1 factorial. And we've got a to the n minus 1, or 1 to the n minus 1 is just going to be 1, x to the power of 1. So just times x to the power of 1 plus nc2, so you're going to get n factorial over n minus 2 factorial 2 factorial. Again, you can have 1 to the power of n minus 2, or 1 to the power of anything is just 1. So therefore we're going to get x to the power of 2 here. And we can continue this pattern on. Sorry, I forgot to put a plus in there. Put a plus in here, and the next term we haven't got it, but we just follow the pattern. We just do n factorial over n minus 3 factorial 3 factorial. 1 to the power of n minus 3 is going to be 1 again. X to the times x to the power of 3. Oops, times x to the power of 3. And we can continue that pattern on. So x to 0 is 1. We said 1 to the power of anything is 1, so this is just equal to 1. We've got our first term there. Look, there's the 1, and here's our 1 here. So let's go on to the next bit. N factorial over n minus 1 factorial 1 factorial. Well, what I'm going to do here is I'm just going to show you how this all cancels down. N factorial is equal to n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. And n minus 1 factorial is the same as n minus 1 times n minus 2 times all the way down to 3 times 2 times 1. And we can see that the n minus 1's cancel, the n minus 2's cancel, and everything cancels and just leaves us n. Over 1 factorial is 1, so we're just left with n. So we get plus n x to the power of 1. Similarly here, the n factorial, all the n minus 2 is going to cancel and just leave us now. So the n minus 2's all cancel, it leaves us just n times n minus 1 on the top. I do also have this 2 factorial. So I'm going to be left with that 2 factorial on the bottom, x squared. And you can see the pattern developing. Hopefully you'll start to see the pattern now. On the top, you can have n times n minus 1 times n minus 2, because n minus 3 factorial and everything below will cancel to leave you 3 factorial on the bottom. So we'll just get n times n minus 1 times n minus 2 all over 3 factorial times x cubed, and you can see the pattern emerging. So you can see you times by one thing less each time, and the factorial on the bottom goes up by 1 each time, and is always the same as the power. So it should be a very easy formula to remember, and it's also on the A-level syllabus a formula that you are given. So this is our formula for this expansion. I'm just going to rub all this out. And we're going to say, well, why is this going to work for negative and fractional indices? How can you expand something that's got a negative fractional power? Well, what happens is this is only valid for certain values of x. It's only valued, okay, when x is between 1 and -1. And you often see textbooks will write that as the modulus of x is less than 1. So if you make this positive, then it's less than 1. Because if you take a value between -1 and 1 and raise it to a high power, it becomes very, very small. So the further you go along in your terms, the less significant this is going to become. And so therefore, the more terms you have, the more accurate you get. But again, you don't need many terms to get a high degree of accuracy in this expansion. So therefore, this is an approximation until you've multiplied out all the terms. But because it's a negative, n is negative or fractional, this series will never end. Okay, it goes on forever, but it gets more and more accurate the further we go. And it's only valid, though, as an expansion when x is between -1 and 1.